Okay, this is one of the most trickiest questions which we can solve. So we have two boxes kept on top of each other. X is being connected to a string. So the block X is having a weight of 10 newtons, Y is 20 newton weight. X is connected with a light string. Now the coefficient of static frictions are given. Coefficient of static friction between the blocks as well as between the block Y and the ground are both zero point 0.2, which means this particular surface on which Y is kept is rough. Similarly, the surface on which X is kept, this surface is also rough. So the question is, we need to find the minimum value of the force F required to move the block Y. And then what will be the tension in the string immediately before the block Y begins to move? So how to solve such questions? All we need to do is just to draw free body diagrams separately for object X as well as object Y. Now, before we do that, let us revise the Newton's third law because that will be very relevant to solve this question. According to the Newton's third law, forces always occur in pairs, in twos, doubles, right? So, look at this example. If a person is pushing the wall, then the wall pushes the person. So, the magnitude stays the same, direction is opposite, and most importantly, both these forces are acting on different objects. So, in this example, one force is acting on the wall, the other force is acting on the person. That's why we say both forces are acting on different objects. And this is the overall definition of the Newton's third law. A exerts a force on B. So B will exert the same force on A, but the direction, of course, is opposite. So the trick to solving this question is, can we draw the free body diagram for X and Y separately? So for simplicity, I will only focus on the vertical forces acting on X and Y. Then we will consider the horizontal forces. So just for the sake of simplicity, I am drawing X and Y separately. So don't think that X and Y are hovering on top of one another. X and Y are actually in contact with each other. But just for the ease of understanding and explanation, I have drawn separate free body diagrams for X and Y. Let's focus on X. Now, the weight of block X is clearly given as 10 newtons. So we will draw an arrow going downwards. This is the weight of X, which is equal to 10 Newton. And since X is in contact with Y, it is going to have a normal reaction force. We will call that as N. Let's call that as N1. So these are the only two vertical forces which are acting on X. Now let's switch our attention to Y. Y, first of all, is having its own weight, which is 20 newtons. So we will draw an arrow going downwards, which will be 20 newtons. Now comes the catch, how to figure out the normal reaction for Y. So hear me out very carefully. Y is in contact with the ground, with the surface. Also, Y is in contact with X. So this means it is going to have two normal reactions. Since Y is in contact with the ground is going to provide Y a normal reaction in the upward direction. So let's write that down. N2. So N2 is the normal reaction which is provided by the ground on Y. And like we discussed earlier, Y is also in contact with X. The value of that normal reaction is N1, but the direction will be opposite. So again, we are using the Newton's third law, which means forces are in pairs. So initially for X, we showed the arrow of N1 in the upward direction. Now to complete the Newton's third law pair, there needs to be a second N1 going in the opposite direction. So where do we draw that? To identify that, we need to figure out N1 is the force acting between which two blocks? It is X and Y. So if one N1 is acting on X, the second N1 will act on Y. So let's draw an arrow. So N1 will be going downwards but acting on Y. Once you can draw the separate free body diagrams accurately, then the question will become very easy. This was the only tricky part. Let's say we are able to identify all these vertical forces. Now let's proceed ahead. In the question, it is mentioned that the applied force F is minimum. That means Y is barely moving. So it is just about to move. So we will assume that the net force acting on X as well as Y will be 0. So let's write it down. The net force on X and Y will be equal to 0. And why have we assumed it? We have not assumed it, we have deduced it since the value of force is minimum such that the block is moving. Since net force is equal to 0, now we will balance the forces. So for X, the upward force is N1, downward force is 10. So N1 will be equal to 10 Let's write that equation. N1 will be equal to 10. Now for y, we have upward forces N2 and the downward forces N1 plus 20. So we will write N2 is equal to N1 plus 20. N1 we figured out was 10. So 10 plus 20, that means the value of N2 will come out as 30 newtons. Now, it's important for us to note what is the importance of the values of N1 and N2. Where will that be used in this question? In the question, it was clearly mentioned about the coefficient of static friction, which means the two surfaces are rough, which means they are having friction. And if we recall the formula for friction, friction is equal to mu times the normal reaction. That is why the normal reaction is important. So if I draw the original diagram one more time, we are having two surfaces, the ground itself and this surface on which X is kept. So the friction on the ground will be mu times the normal reaction. And what is the normal reaction given by the ground? That was N2. N2 was the normal reaction given by the ground. And the value was 30 newtons. So friction, which is given by the ground, let's call that as Fg. That will be mu, and the value of mu is 0.2. So 0.2 multiplied by 30, which comes out as 6 newtons, which means the ground is giving a frictional force of 6 newtons. Now let us identify what will be the value of friction given by this surface on which X is kept. So the formula stays the same, mu times the normal reaction. Mu also stays the same because mu is same for both surfaces as mentioned in the question. So the normal reaction will change. So what is the normal reaction acting between X and Y? So we already reduced, that was N1. Let me repeat, N1 was the normal reaction force acting between X and Y, and N1 was 10. So the value of F will be 0.2 into 10, which will come out as 2 newtons. So let us summarize. The friction provided by the top surface will be 2 newtons, and the friction provided by the ground is 6 newtons. So we are almost done now. All we need to do is to draw free body diagrams, this time horizontally. Because initially, if you recall, we drew the separate free body diagrams for vertical forces. Now we will identify what are the forces acting on X and Y in the horizontal front. So let's proceed. So let me draw the same diagram again. So we have X and Y. Let us try to draw X and Y separately. So X here and Y on the bottom. All right, here we go. So applied force F is acting on Y. So let's draw that arrow first. Now, because of this applied force, Y will have a tendency to move towards the left hand side, which the ground will try to resist, which means Y will have a frictional force coming from the ground towards the right hand side. And the value of this we had identified as 6 newtons earlier. So on the right hand side, we will have a 6 Newton force. Now, if we focus on X, X is connected to a string. String means we will have to incorporate tension in the string. So tension is along the string and going away from the object X. So tension is going rightwards. Now this is where it gets tricky. Because of this applied force F, Y has a tendency to go towards the left hand side. So earlier we saw that the ground was opposing it. That's why the friction provided by the ground was right side. Similarly, X will also resist the motion of Y. So let me repeat, because of the applied force, Y has a tendency to go left side, but X will resist it. So X will give a frictional force to Y in the opposite direction. So let me write friction acting on the top surface of Y, which is provided by X. And what was the value of that friction? Friction between X and Y was 2 newtons. So let me write this friction will be equal to 2 newtons. Let me repeat one more time. Where is this friction coming from? Because of this applied force F, which is towards the left hand side, Y has a tendency to go left side, which X will try to oppose or resist. That is why to oppose it, X is going to provide a friction to Y in the rightwards direction, which is 2 newtons. Now, we are not done yet. Remember the Newton's third law, forces are always in pairs. Both forces are having the same magnitude, direction is opposite, but both forces act on different objects. So we'll use that concept here also. So far, we have identified the value of friction on Y towards the right hand side, which is 2 newtons. Now, according to the Newton's third law, every force is in pairs, is in doubles. So if I can see one friction, 2 newtons going towards the right side, there needs to be a second friction which is going towards the left hand side, but the magnitude should be the same. So this 2 Newton force should act towards the left hand side, but on another object. So which is that object? So going back to this image, the friction which we identified 2 newtons, this was the friction acting between x and y. So x and y are the two objects. So if one friction is acting on y, the second friction will act on x in the opposite direction. So this friction will be equal to 2 newtons. And now we can see that this left friction and this right friction acting on different objects x and y, this satisfies the Newton's third law, which states that every force occurs in pairs. Now, this completes our free body diagram of the object. So we have drawn different force diagrams for x and y separately. Now, all we need to do is just balance the forces. Since we already deduced that the net force on the object is equal to 0, let us try to balance the forces. For x, the rightward force is tension, and on the left, we have a 2 Newton force. So clearly, we can say the value of T is equal to 2 newtons. And similarly, if we balance out the forces for Y, on the left hand side we have F, on the right hand side we have 2 and 6 together in the same direction. So we will add it, 2 plus 6. So the value of capital F, the applied force, will be 2 plus x, which will come out as 8 newtons. So F is 8 newtons and T is 2 newtons. Let's see which option is correct. So the value of force is 8 and the tension is 2, which means A is the right answer for this question. And let us quickly revise how did we solve this question. All we have done is drawn the free body diagrams for x and y separately, but first we draw the separate diagrams for vertical forces, and then we draw the separate diagrams for horizontal forces. And the last step is just to balance out the forces. And that's how we solve this question.